Good day. Welcome to our lesson. On this lesson, I'll be talking about hyperbola graphs. So, if you are new to the channel, please go through the playlist and see other type of graphs that we've covered so far. And then I'll advise that you go through them first, and then you can come and back to this lesson, or you can start with this lesson, then go and watch other videos later on. So, without wasting any time, I'm gonna go straight to this graph, which is hyperbola. So first thing first, we know whenever we are drawing a graph, you must always have the y-axis, which is this side, and then the x-axis, which will be this side there. So from what we know, just try to cancel that y there, looks so terrible. So what we know so far from previous grades is that all the x values which are on the right side, this side, you get positive x values. Then on the left side, we get negative x values. When it comes to y values, all the y values which are above 0.0 are all positive y values. The ones which are below 0, they're all negative y values. That plays a very important role when you're drawing graphs, all type of graphs, whether it's cubic graph, whether it's parabola or an exponential graph. That is very important. So within hyperbola graph, the most important thing that you must know first is the equation, because each graph has its own unique equation. So whenever you're dealing with the hyperbola graph, for example, you can use y there, or you can use fx or gx or hx now. So the equation of a hyperbola, it's a over can be x minus p and then plus q there. So a typical equation of a hyperbola looks like that. That's a q. That's a, that's a q. So it's a typical equation of a hyperbola. So on that equation now, you've got your a value, which can either be negative or positive. Then you've got this guy p, and also that guy q. So these two guys are very important also on your hyperbola graph. So you must always know that p and q values, they give us what we call asymptotes. Ne? So those two guys, p and q, on your hyperbola, they give us what we call asymptotes. So this is very unique because on other graphs, for example, on a parabola graph, p and q, they give us the turning point coordinates, but on hyperbola, p and q will give us our asymptotes. So always remember, p and q, they give us the asymptotes. So now that that is covered, let's also just go through our asymptotes, how to find them. So we know already about p and q. So let's say we're given an equation. Just call the equation y is equals to, let's say, -3 as our a, and over, let's say, x minus 2 and then plus 4. Let's say that is our given equation. Then they ask us to find the equation of asymptotes, or they ask us to find the asymptotes. So to find the asymptotes, you must look at, remember the equation of hyperbola looks like this now. Just put this sign like this, we can always refer to it. We know about the equation of hyperbola looks like this. Could be x minus p there plus q. That's a typical equation of a hyperbola. We know that. So now we need to look at our given equation. We're given -3 over x minus 2 plus 4. So now remember, p and q will give us asymptote. The value of p and the value of q, they give us the asymptotes. So in our given expression, automatically you see that the value that you're given this side, it's our q. So you know that q is what? Is 4, or just say a positive 4. That is your Q that is given to us straight away. So now when it comes to P, be careful guys. If here you're given, for example, X minus a number, therefore P will become the other sign. For example, here is -2, then P will become positive 2. Just be careful of that. If it's X minus 2, your P becomes positive 2. If it was X plus 2, P would have been negative 2. So to prove that, for example, we already know in maths that if they're telling us that it's X minus 2, therefore we know that for it to end up like that, P should be a positive 2 value. That should be our P, a positive P value, because we know that negative and positive will come back as negative. So we know that negative and positive come back as negative. So if it's like that, therefore our P was a positive value. But if now it's given to us as X plus 2, for example, now we know for it to end up like this, for us to end up getting that positive sign, we know that if it was negative before, P must be negative 2 for us to end up with a positive 2, because we know that in maths, negative times negative times this negative will give us a positive answer. So if it's X plus 2, therefore P was negative 2. But if it's X minus 2 here, given to us here as X minus 2, therefore we know P must be a positive value. Just be careful of that. With Q always come back as it is. If it's negative 3, it will come back as negative 3. That's Q. But P, the sign must change. Let's say now, just also get used to writing fx. Let's say they give us fx now as another practice example. Let's say we're given fx now, and then they're saying it's fx, and then they're giving us 2 there as our a, and then we're given x plus 6 now, and then here is minus 3. So yeah, again, quickly, if you want to do it first, you can do it now. Just pause the video and attempt it. So now that we're given it like this, you can start with your P or your Q. Does not matter what order you start with. So if we know that when it comes to P, P is the value that you get here. So here you're having plus 6. So we know that for us to end up with plus 6, because you know that the equation will be minus, for us to end up with plus 6, therefore P should have been negative 6. For us to give us negative times negative, which should be a positive answer. So meaning, in other words, we know there that since it's plus, P will be negative 6. Q, we know it come back as it is, which is given to us as negative 3. This will be our equation of asymptotes. So that will be P is equals to that, Q is equals to that. Or they also accept, you can use P as X, meaning X will be equals to minus 6, because they can also accept it like that, meaning X will be equals to minus 6, and then Q will be your Y, which means Y will be equals to minus 3. So you can use them either way, they will still accept your values. So that will be your asymptotes, which will be given to us. So quickly, I want to also draw these asymptotes on the graph to show you guys how they're gonna look like on the graph now. So I'm going to just erase this part here, because I want to show you guys how you can represent your asymptotes in a graph now, because they always ask you guys to draw the graph afterwards. So I want to show you guys how to represent your asymptotes in the graph. So I'm going to keep my asymptotes as they are. So let's just show you guys how to represent that in a graph. Let's say I have my graph there, which is not even straight. By the way, you guys, at least you'll get a graph paper. That will be X, and then that will be Y there. So first thing first, we know on the first one, I'm going to do the first one first, and then I'm going to do the second one. So I'm doing the graph of this asymptote here. So I'll just be showing you guys the asymptotes now. So first thing first, you must know that we've got the horizontal asymptote and the vertical. So we know from previous grades about horizontal. If a line is horizontal, for example, it will go like that. But if a line is vertical, it will go like that. So we know about the horizontal and also vertical. So now when it comes to our asymptote, we know we've got 1 at x. The one that is at x is what? Giving us 2. So just go to your x axis and have a positive 2 there. We know the one that is at y is giving us a positive 4, which will be somewhere around that line. So now that gives us where our asymptotes will be. So our first asymptote will be the one at x. Just draw the dots which are cutting through your x or your p value. Then they just go and down as continuously as they can be. Then the ones that are going through your y, just do the lines like that, which will be going like that. So now that will give us a hint that whenever you draw the graph, your graph must never touch the asymptotes, meaning it must curve away from the asymptotes. For example, we can have my graph here like this, curving away from the asymptotes, or you can have it like this, also curving away from the asymptotes. Now, the most important thing that will determine where your graph will be your intercepts, which I'm going to do after this. So your intercepts will tell you where your graph will go, which you'll see as we do the intercepts. So just know about the asymptotes. The P1, just draw the line going downwards. And then for the Y1, just draw the line just going vertical. That will be your 2 asymptotes for this given graph. So for the second graph also, just want to quickly draw a small graph here and show you guys how you will represent the asymptotes now. So we know for so far that we're going to have x that side. My x is trying to act dramatic. Okay, then you're going to have y there. So we know so far about our asymptotes that the p1 is -6. So meaning x would be -6. So you go to the x-axis and put -6. This would be nice if you're given a graph paper. Even if you're not given a graph paper, as long as you can just represent and show the -6, it's fine. They won't penalize you guys for accuracy in this section. I know that in previous grades, especially in lower grades, they always penalize you guys for a scale. Here they don't really check much the scale. They want to see the value, where the value is, and the shape of the graph. So x we know is -6, and then y, remember it's your q. Q is -3, so you must go on your graph where y will be negative, which will be somewhere around there, maybe -3. Now we know the p asymptote. You just go there and so for p asymptote, just go there and put your asymptotes going downwards, like that. Then for the q1, we know that the asymptotes will go like that, cutting from your q. And then we know when you draw the graph, remember it must, when we draw the graph, our graph will go like that, curving away from the asymptotes, because it must never touch the asymptotes. And then same thing can apply this side. It can curve away from the asymptotes. So you can have those 2 as your graphs, depending on your intercepts. So those would be 2 type of graphs using only the asymptotes. So I want to also guys show you now how we can draw a graph. For example, if maybe we're given the intercepts, because so far we're only given the asymptotes. Let's say now I quickly erase this. I want to show you guys how you can draw a graph now. Let's say we're given the intercepts now. So okay, let me not remove this. Okay, just remove that part there, it's fine. So I'm going to use the same equations now just to show you guys how the shape will now be allocated depending on our intercepts now. So I'll show you guys how the will now be affected by that. So I'll show you guys how now the intercepts will affect our graph altogether. So everything else will remain the same. So my asymptotes will remain the same, but I just want to now play around the intercepts. I'm checking these ones out because assuming that you guys already have them written down. Not that part. Okay, it was +6 here. It was +6. Okay, so I've got that now. So let's quickly also this graph disappeared as well for whatever reason. So it's fine. Just go there and put the x. Okay, it's fine. So now let's find the intercepts now. So let's quickly find. I'm just gonna put them the two of them this side. Let's quickly find the x-intercept first. Now we know when we are finding the x-intercept, the value of y must be 0. Né? Don't forget that when you are finding the x-intercept, the value of y must be 0. That is the rule. Né? Whenever you are finding the x-intercept, the value of y must be 0. And then whenever you are looking for y-intercept, the value of x, or wherever you see x, it must be 0 né, on y-intercept. So wherever you see x, it must be 0, or the value of x will be 0. That will be your y-intercept. Né? So that's your graph now. So now let's quickly find those two for that first graph there. So the x-intercept, y must be 0. This is our y there. Even if it's fx, just whatever there's fx, you must put a 0. Né? Or whatever there's a gx, you must put a 0. So wherever I see y, I'm going to put a 0. That will be minus 3 there. And then over x minus 2. And then plus 4 né, as our given equation. So first thing first, when you're given this type of equation, né, take the number that you have here, the other side. Here we've got positive 4, meaning the other side it will come back as negative 4. Né? So the number must jump the other side. So it will come back as negative 4. And then here you'll end up with minus 3 over x minus 2. Né? That's our given equation. And then we know from now onwards, you can just divide this one by 1. And then from there onwards, you can do cross multiplication. The number that you have down there will multiply that one. The one that you have down there, which is 1, will multiply that one now. So when you simplify this, it will take us to, it will be negative. Just put them this side now. I'm going to squeeze them here. It will be negative 4. It will multiply x minus 2 now. To multiply x minus 2. And then the whole thing will be equals to 1 times minus 3, which will come back as minus 3. Now. Come back as minus 3. So from now on, we're going to simplify. Negative 4 times x will be minus 4x. Minus 4x. Now. And then negative 4 times minus 2, that will come back as 8. Now. And then is equals to minus 3. Now. So now we can simplify this further now. It will be negative 4x is equals to 3. So it's equals to negative 3. Sorry for squeezing this thing in the negative 3 there. Then minus 8. Negative 3 minus 8. And then we know we can simplify now. It will end up as minus 4x. Because so negative 3 minus 8, that is negative 11. That is negative 11. So we divide everything by negative 4, meaning our answer will end up as x will be 11 over 4 as our x-intercept. X will be 11 over 4 as our x-intercept, meaning the coordinate of my x-intercept will be 11 over 4, which is your x. And then the y coordinate, remember, it will be 0 because it's our x-intercept. That will be your answer, 11 over 4, and then also 0 as your coordinate. Remember, here it's the coordinate, it's 11 over 4 and also 0. That is our x intercept. So now remember, we need to go and find the y intercept. So for y intercept, x must be 0. Wherever you see your expression, x must be 0. So I'm going to put it here in the meantime. So to find the y-intercept, so my y-intercept will come here now. I'm going to put it, squeeze it here. So my y-intercept, wherever we see x, it will be 0. So we'll go back to the normal equation which is given to us. So it will be y is equals to minus 3 over x minus 2 as it was given to us on the equation, and then plus 4 plus 4 there. So we know wherever we see x, we're going to put a 0. So it just come back as y would be equals to minus 3, and then wherever you see x, we're going to put 0, and then 0, and then minus 2 and then plus 4. So that will be your answer. So if you put the whole thing in a calculator, it will give you the answer straight away. So it will be negative 3 over negative 2 plus 4. Let me quickly do that in the calculator. So it will be minus 3 divided by minus 2 and then plus 4. So it's giving me 5,5 now. So that whole thing is giving me 5,5. 5,5. So now this means that my coordinate now x is 0. Remember, because we're doing the y-intercept. So x is 0. And then y is 5,5, which is our decimal. So that will be your y-intercept coordinate. So to also make the other one also fair, let's get it as decimal. The first one was 11 over 4, 11 divided by 4. So it's like around 2,75. So the coordinate that you're getting here on x, we're going to have, remember, first ones we had were the asymptote, which was 2. So we had the asymptote, which was 2 here. So first thing first, we had the asymptote, which was 2. So now you need to go and put everything that we found. We had the asymptote before, which was 2. And then now the intercept that we found is 2,75, which will be somewhere around after 2. So it will be like around there, 2,75 after 2. So those are, that's my intercept there, meaning that's where the graph will cut now. Then the other asymptote we had, it was at 4, which was around here. So now we've got those asymptotes. First thing first, let's put our asymptotes. So that will be our asymptote there. Then our other asymptote will go like that. So we've got those two asymptotes now. So we know about our intercepts now. The other one it's at 5,5, which will be above there. So it will be above there, which is 5,5. It's 0 and 5,5, which will be somewhere up there. I'm just trying to erase this and at least have all the values being clear. So I can't have 4 up there. It's not working out for me. It's trying to have all the values there and just to show you guys how the asymptotes will look like. So we're gonna have all those points now, which is first thing first, let's put our asymptote. We know we've got 2 there and we've got 2,75 as our x-intercept, and then we've got 4 there, and then we've got 5,5 as our intercept. And now we know about the asymptotes, that the first one, the x1 will be like that one, then the y1 will be like that, and then to just go like that. And then now we know the graph will cut x there. So we know that if the graph is cutting x there, it will go like that, it will cut x there, but remember it will be curving away from the asymptotes there. So whenever you throw it, just show your teacher that it's curving away from the asymptotes there. So whatever you do, just make sure that it's curving away from the asymptotes. Let me use a different color just to show you how the graph this side will look like. It will be curving away from my asymptotes, and then it will go like that, but curving away from the asymptotes. And then the other one, we know it's cutting y there. It must cut y there, meaning also it will just come from somewhere up there, then it will cut to it, and then just bend away from the asymptotes. It also bend away from the other asymptotes. So your two shapes of the graphs will look like, and that. Don't forget to put your x and also your y in there. So that's how your graph will look like. It will be bending away from the asymptotes. So that's how you will use that given graph to find your given asymptotes there. So also just want to quickly also do an example now for the second part now. Just want to do for the other example, just to at least do 2 examples to show you guys how the intercepts are going to affect everything now. So here we've got that. Show you guys how the intercepts are going to affect everything. Just trying to have at least a lot of space now, so that at least my graph can look more neat and more clear. But I'll do more examples on the video just to show you guys how to do more and more. So that one is the previous example. So what I'll do for the second one now, just to give you guys more practice. So if you are already confident, you can start doing the graph for the second one before I do it now. So you can do the intercepts quickly and then start drawing the graph. and how it will look like, and then you will tell me in the comment section how your graph looks like now. So let's start with the x-intercept again. Now I'm doing for this one. So now my focus is on this graph. Now I'm focusing on this one. So let's do the x-intercept first. We know now y is the same as fx. So whenever you see fx or y, you put a 0. So it will be 0 is equals to 2 over x plus 6. X plus 6 and then minus 3. So again, the same concept applies. The 3 must go the other side, which means it will come back as positive 3 the other side, and then it will come back as 2 over x plus 6 this side. So that will be our graph there. It will come back as our equation, so x plus 6 there. And we know we can divide here by 1. So meaning it will be cross multiplication and also cross multiplication. So we know now it will be 3 will multiply x plus 6. 3 will multiply x plus 6. And then this whole thing will be equals to 1 times 2, which will come back as 2. So now we'll just simplify. 3 times x will be 3x. And then 3 times 6 will come back as 18. Back as 18. And then the whole thing is equals to 2. Then from there onwards, it will be 3x will be equals to 2 minus 18. 2 minus 18. So meaning this will come back as 3x will be negative 16. Negative 16. And then we'll just divide everything by 3, also by 3. So my x-intercept here will be negative 16 divided by 3, which would be, I know it's above 5, it should be 5 comma something. So it's negative 16 divided by 3. It's negative 5,3, negative 5,33, which is recurring. So meaning the coordinate that I'm getting here will be negative 5,33, and then remember the y value must be 0. The y value must be 0. That will be our coordinate there. So that's the first one. And then to find the y-intercept now, remember x must come back as 0. So it will be y is equals to, and we've got 2 there. X must be 0, which will be 0 plus 6 and then minus 3. So that will be simplify that. So that will be 2 over 6. So it's giving me negative, as a decimal, it's giving me y is equals to negative 2, I'll say 67. 2,67. So meaning the coordinate, remember x must be 0 here on y-intercept, so to be 0, and then minus 2,67 as our y-intercept. So that will be our 2 intercepts. I've got this one here and also that one there. So now we already have the asymptotes which were given to us based on the given graph. So now we just need to have space. Let me try to make this graph look a bit bigger now, so I can at least expand it. Let's have y there. Okay, now let's have those 2 intercepts. The first one we had was negative 5,33, which will be before negative 6. So you'll expect to have it somewhere around there. The negative 5,33 before negative 6. And then the second one that we had, the y-intercept, where to cut at y, it's cutting at negative 2,67, which is before negative 3. So it'll be somewhere around there. So we've got those intercepts now. So now remember it cuts x there, but before you do the intercept, do your asymptotes, because we know that the other one is passing through 6, and then the other one is passing through minus 3. So those are our 2 asymptotes. First do the asymptote before you do the intercept. So you do the asymptote first before you do the intercepts. So now that I've got that, I know my graph must cut x there. So my graph is cutting x there. It must never ever jump my asymptote or touch my asymptote. So let me just use a different color. So this one is the one that I love the most because it's showing us, it's just combining one thing at once. So it will go like that, it will cut X there, and then it will cut Y there. See, it's bending away from the asymptotes. On the first one, we had two defined graphs because our graph couldn't jump our asymptotes. So if they can't jump, just do the X intercept alone and the Y intercept alone. And then here it's next one because it's going through both intercepts. Same thing will happen. Another image will be formed. We can have another image forming this side, for example, like that. Also, it will be bending away from the asymptotes. So this would be how to draw the graph. It's mostly for 4 marks because they ask for equation of asymptotes, then they ask you to draw the graph and stuff like that. So yeah, I hope that was helpful, those two examples. So I'm gonna continue now with other points. So we also have got what we call domain and range. So always know that when it comes to domain goes with X, range goes with Y. So domain goes with X, range goes with Y. So if you look at your any graph, for example, it has got X and Y now. So therefore, my domain is this whole region that is going through X. That is our domain. Range will be from here going upwards, or from up going downwards. That will be your range. It affects your Y axis. Domain affects your X axis. So when it comes to hyperbola, your asymptotes are very important. Your domain, just call it D, your domain will never ever touch where you have an asymptote. Your domain will never touch where there's an asymptote. So always know that the domain will never touch where there's an asymptote. It will never ever touch that. Same thing, the range won't touch where there's a Y asymptote. So domain, let's say I'm having an X asymptote, and let's say -2, it's our X asymptote. Then let's say we've got 4 as our Y asymptote. Let's say that's our asymptote there. That's our asymptote there. And then let's say that is our asymptote there. So I've got those two asymptotes. And let's say they're given to us. So the domain will be all real numbers. So we call it X, element of all real numbers. But X can be where there's an X asymptote. So meaning X can be -2. Just put a line on the dash there. That domain will be X will be element of all real numbers, but X can be -2 because we're having an asymptote there. That will be your domain. Now your range will be, remember, range goes with Y. Range will be Y element of all real numbers, but Y can be 4 because 4 is the Y asymptote. That will be your domain and range. Again, like previous, I'm going to give another example just to prepare you guys. Let's say now they give to us as an equation, and then they just tell us that we've got, let's say 3 over x plus 1, for example, and then -2. That's a given equation. First of all, we know from the given equation we're having these two asymptotes. Our first asymptote that we're going to have on that equation will be x will be -1, and another one will be y is equals to -2, or you can say p is -1 or q is -2. That will be our asymptotes. These two, this will be our asymptotes. So if they ask us to find the domain, we know that domain will be element of all real numbers, but x won't be where there's an x asymptote, meaning x can be -1 in this example. Then for range we know it will be y element of all real numbers, but y can be -2 because -2 is the asymptote of y. That would be your equation, our domain and range. So domain goes with x. It will never be where there's an x asymptote. Range goes with y. It will never be where there's an y asymptote. They'll give you 2 marks for that. Just saying for domain and also for range. Could always ask them. Either they ask you for domain or they ask you for range in exam if you're dealing with a hyperbola graph. So I hope those 2 examples help you guys. If not, please comment on the comment section. I'm more than happy to do more examples just to show you guys to get these marks. So one thing that I also want to go through is what we call axis of symmetry. So whenever you're dealing with hyperbola, whenever you talk about axis of symmetry, just think about your normal straight line graph, which is equals to mx plus c. We know about the normal graph of a straight line is y is equals to mx plus c. So now when you think about axis of symmetry in this section of hyperbola, think about that equation, which is y is equals to mx plus c. So we know if they're saying we've got a positive gradient, remember from the previous video, m represent the current. So m represent the current in the equation. So in this equation, m is the gradient. So meaning if you've got a positive gradient, therefore you must have a positive m. Your m value must be a positive answer. Same thing applies here. If gradient is negative, therefore must have a negative m value. So if we were to do the equation, for example, let's say let's use an example where m is 1. If they don't give us m, just use m as 1. So if m is 1, therefore we know that it will be y is equals to m is 1, so it will come back as 1 times x, and then plus your c. Let's say you just give c as 2, for example. Let's say we're going to use c as 2. Let's say our c is 2. Yeah, let's say our c is 2 now. Then that means that we're going to apply that, and then now from here onwards, we know that 1 times x will come back as x now. So this means that my equation will be like that if it's a positive current. But if it's a negative current, it will be -1 now. It will come back as -1 because m must be negative. There m was positive here, but there m will be negative on the other side. So it will be -1 times x plus 2, for example. And then that will be -x plus 2. That's when if they give us m as 1 and then c as 2. But if they don't give us those 2 values, you must always remember your asymptotes are very important here. So your x and your y asymptotes are very, very, very important. So wherever you in the equation, let's say this is our equation. Let's say we have this equation. If they want us to simplify or to do anything, wherever you see x, you can put the x asymptote. Wherever you see y, you put the y asymptote. You'll see when you do examples. So if they ask you to do something or simplify, wherever you see the y asymptote, put the y, put it on y. Wherever you see the x asymptote, put it on the x. That's why the asymptotes are very crucial in this regard. So let's say now, remember so far I've been doing equations where they're giving us sort of like the equation is y is equals to 2x plus 3 then over something. Now let's say now they give us the graph and then they want us to go and find the equation in that format. For example, let's say we're given now the graph and then they're asking us to go and find the equation in that format. So first thing first that you must ask yourself, we've got the asymptotes. We know that it's P and Q. Before you do anything, just go to your equation, because we know that you can just put it as fx sort of y. Just put the equation as fx. So first thing first, before you do anything, just go and put your asymptotes. We know that they are there on the graph now. We're given our asymptotes on the graph. So first thing first, just put them as they are now. So we've got A, which will come back as it is, because we don't know what our A is. And then we know it's going to be x here. And then we know we've got -2 as the asymptote there. If you have -2 there as your x asymptote, Therefore here it was plus 2, because we're having our x asymptote here s minus 2. Therefore here it was plus 2, because this is plus 2 here, there it comes back as negative 2. And then we've got this one here, which is our q. It's, remember, the q sign will come back as it is now. So it will come back as plus 3, because it's in a positive 3 there. Those are the two asymptotes that we have. Now that's fine. Now remember, we're not done. We need to go and find the value of a, because the equation must have everything written down there. So to find the value of a, you must always use the other point in the graph. Ne? To find a, use the other point in the graph. So you need to go and look at the graph and see, am I having another coordinate? Yes, you see here, my graph is cutting x at 4, meaning this point here, my graph is cutting x at 4, meaning that point there is our x-intercept. Remember, if it's x-intercept, y must be 0. So it will come back as 4 and 0. That will be your point there, because it's cutting x at that. So that will be your coordinate based on the graph, what the graph is cutting. If the graph tomorrow was cutting, let's say at y, for example, let's say it was cutting somewhere there, and then they put -2 there. Therefore, you will know that that point, remember, is cutting y, therefore x must be 0. Ne? Then the coordinate would have been -0 and -2, if that was the given equation to you. But because we're given that one, we'll focus on that one. Ne? So I'm going to erase this part, that doesn't confuse you guys. So just be careful of that. And then now we're given a point. To find a, you need to use that point. Ne? So we know about the coordinate. It has got to x and y. Remember, this is x, this is y. Ne? That's your coordinate. So wherever you see x and y, you're going to put that. Ne? We know that y is this side. So we're going to put 0 there. And then this will be equals to a that I'm looking for over x. We know it's 4 plus 2. The asymptotes will come back as they are. Ne? Because the aim is to find a here. Then plus 3. Ne? Then from there onwards, again, the 3 can go the other side. Ne? So it will come back as -3. And then is equals to a 4 plus 2. We know it's 6. Then from there onwards, again, divide by 1 and then do cross multiplication. Ne? The 6 will multiply -3 and then a will multiply 1. So 6 and -3 will give us -18. Ne? 1 and a will give us a. Ne? So meaning a is -18. So now that means that our equation will be fx will be a is -18 over x plus our p, which is 2. Then our q is 3. So that will be our equation for 4 marks now. That will be your fx equation. So first thing first, put your asymptotes as they are. Ne? Then go and look for a point on the graph. That point on the graph will give you x and y. Then you put those x and y to go and solve for a. Same thing applies to all the other graphs, which is either the parabola, the exponential, all of them. They can use the same method if you go and find the value of a. Yeah? So now let's also have a practice question, which will help us before we do some exam past questions now. So with a practice question like this, for example, first thing first, we're given an equation. It's fx is equals to -3 over x plus 2, then it's -3 over x plus 4, and then plus 2. So we know that p comes from here, q comes from there. No? So if they ask us for example, the first question, they're asking us for the equation of asymptotes. No? We know about the asymptotes that the x1, it comes from there. There we are having plus 4. We know that the asymptote will come back as -4. Ne? If it's plus, the x1 will come back as minus. So it will come back as -4. But the y1 will come back as it is, ne? Which is 2 there. The sign come back as it is. Or you can say p is -4 or q is +2. Ne? Either way, it's fine. So that will be the first. It's 2 marks, by the way, guys. They give you a mark for that and a mark for that, just to do that. And then domain and range. Okay, we know about domain that it will be x element of all real numbers. No? but x can be where the same x asymptote, which is -4 in this instant. Then you get your 2 marks again. It will be x element of all real numbers, but x can be -4. That is for domain. Ne? For range, remember range goes with y. Ne? So for range, it will be y element of all real numbers, but y can be with an y asymptote, which is 2. Then that's it. And that will be 2 marks each. So by now we'll be having 4 marks, which is nice to get, by the way. So now let's go to, okay, they're asking us to find the intercept. So let's find the x1 first. So remember, with x-intercept, we know that the value of y must be 0. So don't forget, with x-intercept, y must be 0. With x-intercept, y must be 0. So now this means that wherever you see y, we know that y is the same as fx there. So it means that there's a y there. I'm going to put a 0 there. Yeah, that's giving us a weird symbol. So I'm going to put a 0 there. So it will be 0 will be equals to, so I'm using the given equation. I'm using this equation which is given to us. So it will be 0 is equals to minus 3 over x plus 4. Because remember here we only focus y must be 0. X will come back as x. Then plus 2. Then from there onwards, we know that the number here, which is 2, must go other side. So it will be minus 2 this side, and then minus 3, and then everything over x plus 4. So now we're going to do cross multiplication. So this will be over 1. So we're going to do cross multiplication. This will multiply that one there. This one will multiply that one there. So it will be minus 2 multiplying x plus 4. And then everything is equals to 1 times minus 3, which is minus 3. And then now we know that it will be negative 2 times x, which will be negative 2x. And then again, negative 2 will multiply 4, which will give us minus 8. And then everything is equals to minus 3. Then from there onwards, 8 will go the other side, so it will be minus 2x. And then it's equals to minus 3 plus 8. That will be our given equation. So now it will be minus 2x here is equals to minus a3 plus 8, that will be 5. So therefore x will be 5 over minus 2. 5 divided by negative 2, which will be decimal will be, that will be negative 2,5. So meaning the coordinate that I'm getting here will be minus 2,5. Remember, y is 0, because we're doing the x-intercept here. Y is 0. That will be our x-intercept. That will be our x-intercept that we have. So it's negative 2,5 and 0. So you can give yourself time and check it down, because I want to leave some space to go and find the y-intercept. So I think I can squeeze the y-intercept this side. Just make a space here to find the, yeah, I can put the y-intercept here. So let's find the y-intercept there. So that will be our y-intercept. We know about y-intercept, x must be 0. X must be 0. So now wherever you see x, going to put a 0. So y will come back as y now, and then it will be over minus 3 over 0 plus 4, and then plus 2 the other side. So therefore just put everything as it is on the calculator, which will be minus 3 over 4. So it will be minus 3 divided by 4 plus 2, which is 1.25. So that's 1.25. So it's 1.25 as your y answer. So meaning now the y-intercept coordinate, remember x must be 0, né? So it will be 0 and 1.25 as our coordinate. So now we've got that. It's nice. That will be worth 4 marks for both intercepts. Né? So I've got my intercepts now, the x1 and also the y1. Né? So now I want to quickly go and draw the graph. So I want to remove this ones that I've done so far and go and draw the graph. I'm going to go and draw the graph now. I'm going to go and draw the graph because the next question they're asking us to sketch the graph. So I want to draw the graph. So I'm just going to go there and put the y there and the x there. First thing first, label, that's x and that's y. Né? So now let's put the asymptotes first. We know we've got -4 where there's x, so -4 will be this side. And then the y1 is 2, which will be that side. And then now, what are the values of intercepts? We've got -0.25 as your x here. That's -0.25 as your x, which will be somewhere around there. -2.5. Then the y1 is 1.25, né? Which will be before below 2, so 1.25 will be there. So now first thing first, remember, do the asymptotes. Né? So just do those lines going through asymptotes. The other one is 2, and then you get your 2 marks for that already. Now from there onwards, we know that just go and put the coordinate. My graph cuts x there, it cuts y there. Né? So meaning it must come where it can become from downwards, but it must avoid the asymptotes. This will be my graph coming there. It will cut my x there, then it will cut my y there, né? Then it will go like that. That will be the shape. It will cut my x there and my y there. That will be the shape of the graph. Né? And then same thing applies here. You can also have 1 here, which will also avoid the asymptotes. So it can be like this, also avoiding the asymptotes. As long as your graph is avoiding the asymptotes, it's fine. Then that will be your hyperbola for that given equation. So that will be that. So yeah. So last question, they're asking us to find the equation of axis of symmetry. So okay, I need to remove this part now because I've already solved my graph. So the graph will also be 4 marks. So you'll be getting 2 marks for the asymptotes, 2 marks for domain and 4 marks for domain and range. Domain will come with 2, range will come with 2 as well. So that will be 4 marks. And then the intercepts will also be 4 marks also. And then your graph will also be 4 marks. So basically for the first questions here, 4 questions here, they're giving us 2, 6, 10, 14 marks. So we're getting 14 marks already in this equation or question alone by itself. So that will be your question. So I just want to show you guys how lovely they are to find the asymptotes, and you guys will see when you do past papers by yourself how easy this section is. Okay, I will also believe that every section of maths is, which is okay, it's not even up for debate. So first thing first, now they're asking us to find the equation of x of symmetry. We already know about equation of x of symmetry, that we know that when I think about the equation of x plus x, x plus c, it will be x plus c as our equation. So but now we know, remember it's mx now, so it should be mx now. Now we know that they're saying a negative gradient. So a negative gradient is giving us a hint that m must be negative now. So it's giving us a hint that m must be negative, because you can get a positive gradient or a negative gradient. So here we know m must be negative. So first thing first, just go and put m as negative. So meaning it will come back as negative x plus c now. And then because now we don't know what c is, we can use the what do you call it, the asymptotes. Then therefore we know that the y asymptote is 2, and then we know that it will come back as negative from the guidance, but the x asymptote, we know it's -4. Those are the two asymptotes, and then plus c now. So therefore now we know that this will be 2 is equals to negative and negative will give us positive now, then plus c, and then now 4 other side, it will be 2 minus 4. It will be 2 minus 4 will be equals to c, meaning my c is 2 minus 4, which is -2. So c is equals to -2, which means now my equation will be y is equals to -x minus 2, as I was saying. That would be your equation for 3 max. That would be our lovely equation for 3 max. So that is my practice question. So just want to also, I found one from a past paper. Just want to go through it with you guys as well. So in this one, again, it's a hyperbola. They're given fx as well. Remember, here, that's where you find your p asymptote, and then here you find your q or your y asymptote. So first thing that asking us, I think now by now you guys must be comfortable. So pause the video and attempt this question first, and then we'll do it together. So I'm hoping that you guys are done now that you have resumed the video. So first thing first, asymptotes again. We know about that one. There it's -3. Therefore, x will come back as a different sign, which is 3. Y1, remember, it come back as it is, and then we're given to us as -2. So they were still with the marks here. They gave us 1 mark. They knew that it's getting easier and easier for us to find it, which is not fair, by the way, but it's fine. So this would be our 2 asymptotes. And then here they're only asking us to find the x-intercept. Okay, but you can't draw the graph if you don't have the other one, because the graph needs both intercepts. So we know about x-intercept, that y must be 0. We know that y must be 0 based on what we know about the intercepts. So first thing first, now we know in our given one, y will be there. So I'm going to put a 0 there. Is equals to 1 over x minus 3, and then -2. So we know now that the number here must go the other side. So to come back as a +2 this side, then everything is equals to 1 over x minus 3. And then now we know that we can divide here also by 1. Then from there onwards, you can cross multiply, also cross multiply. So here we know that it will be 2, and then multiplying your x minus 3, and then is equals to 1 times 1, which will be 1. So 2 times x will be 2x. 2 times -3, that will be -6, is equals to 1. And then we know that 6 will go the other side, so it will be 2x. 2x will be equals to 1 plus 6. 1 plus 6, which will be 7. So this will, what is that? So therefore it will come back as 2x will be equals to 7 divided by 2. So meaning my x will be 7 divided by 2. X will be 7 divided by 2, because you divide both sides by 2. So x will be 7 divided by 2. So meaning my x asymptote here will be 7 over 2 and 0, because y is 0. And then also, let's find the other one, the y-intercept. Let's find the y-intercept as well. Let's find the y-intercept. We know about the y-intercept that x must be 0, because we can't draw the graph if you don't have the other one. So you have already found our x. That's our answer. But let's find the other one so that we can draw the graph. So with x-intercept, so y-intercept, x will be 0. So just go there and put y as it is, and then 1 over 0 minus 3, and then -2. So that will be 1 divided by -3. So it will be 1 divided by -3, and then -2. So it's -2, 33. So it will be y equals to negative comma 233. Yeah, so therefore we know x is 0 here, so it will be 0 and negative 2,33. Negative 2,33 as your y-intercept. So here it's 7 divided by 2. I want to leave it as a decimal as well. So we know that will be 3,5. Yeah, 3,5. And then 0 as a decimal because it's easy to draw a graph with a decimal. So now, so remember for this second equation, you'll end up here for the second equation for 3 marks. Then they want us to draw the graph. Okay, nice. Draw the graph. We know that we can have our x there, and we can have our y there. First thing first, let's put our asymptotes. We've got 3 as our asymptote there. We've got the other one is negative 2, which will be down there. Then our intercept, we've got 3,5, which will be somewhere around there. That's what the graph will cut x at. And then the other one is negative 2,33, which will be somewhere around there. Negative 2,33. So we've got the points where the graph will cut. So first thing first, remember, show your asymptotes that they are, then show the other one. So we know that the graph cannot go through those. Now we know that the graph is supposed to cut x there. So meaning, just choose a different color. Meaning my graph will now can just come from this side, but it will bend away. It will cut there, but it will bend away from the asymptote. Then the other one, we know it must cut my y there. So also it will avoid my asymptote. It will come like that, and then it will go down to avoid my asymptote. So this will be my 2 graphs that I'll get from this. And that is 3 marks for that. Okay, that's nice. So that's that. So we are left with axis of symmetry. Okay, let me quickly do that. Let me just get the space here because I'm out of space here. Let me remove this. I'm assuming that you guys took it. If you didn't, go back to the video and just get those values. And then please, if by at this point maybe you guys are getting lost by something, I'm gonna advise that you probably comment, because I'm gonna make this video a premiere that you can see if you guys are comfortable, and then maybe I will do a live session very soon, which I think it will be much better that we can communicate as we're going through this together. So now first thing first here, we know about the equation. It will be y equals to mx plus c. That is your equation. And then we know about the gradient is positive 1. So to save time, we know it will come back as m will be positive. So it will come back as x plus c, because we're having a positive gradient now. So it will come back as m is 1. So it will come back as 1x plus c. So we know about asymptotes. Remember your y asymptote and also your x asymptote to go and find c. We know about our y asymptote, it's minus 2. And that's given to us as minus 2 on the given graph. So we've got minus 2 as our y asymptote, and then we know that the x1 is what? Is 3, and then plus c. So we know that this will be negative 2. The number will go other side, becomes minus 3, and then the whole thing is equals to c. So this will be minus 5 is equals to c. So we know that the equation will come back as y is equals to x minus 5. And then that's it. That's your axis of symmetry. 2 marks. Okay, maybe they're tired of giving 3 marks. Okay, I think it's fitting 2 marks, that one. So I think doing a lot of examples also help. And I'm hoping again, guys, that you are comfortable, or at least getting comfortable with this. Because according to me, these are the type of questions that you must always target. The whole thing of maths, it's easy to target. So if you are new to the channel, please go through our playlist and see all the other topics we have covered so far. So now they're asking us about the transformation. Okay, so we've got f, which was given to us. Then they're telling us that f is going to hx, and it's forming that. Okay, first thing first, we know that our -2 disappeared. Okay, and then our -3 also disappeared. Ne? So okay, on a normal graph that we had before, we knew that we had 3 as our asymptote there, and we had -2 as our asymptote. These were our 2 points of asymptotes. Ne? Now we are having them as zeros, meaning there's nothing anymore at -3 here. So meaning here, before I was here, we were here before, this was our point. Ne? Now we're at 0, so meaning we've gone from here to there, because 0 line is here. That's our 0 line. So we've gone from 3 to 0, meaning we know that from here to the other side, we're going to the left side. Ne? This is us going to the left side. So we're at 3 before, now we have gone to 0. This means we have moved 3 units to the left, ne? Based on our new hx. So we've moved 3 units to the left. So we've moved 3 units to the left based on that x1 alone. So we've moved 3 units to the left. Ne? And then now also again, remember on the y-axis, before we were at -2, now we are at 0 also. So we're here before, now we are at 0. Again, we're going to 0, which means we have gone up by 2 units. So the other part will be 2 units up. Ne? So that will be our interpretation of a new graph. 2 units up, and then that will be that lovely 2 marks, 2 units up. And then again, I feel like it's always easy to do another example now, because I know some of you will be shocked by that. What is it talking about? Y plus up, or what the hell? So let me just give another one. Let's use the same f that we have there. Let's say I'm using the same f that I'm having, but then now let's say we're given a new hx now. Now we're having a new h. Maybe my new h now must just be different. Let's say now our new h is like this now. Let's say now we're having a new h being like this now. Let's say it's 1, of course, will remain as our a, and then we have got x plus 1 now, ne? And then we're having 3 now. Okay, that's our new hx. And then they ask us again to describe the transformation now. So again, remember, let me use the same graph that I use. Just want to use the same graph now. Okay, we know before we were at, on x, we were at 3 before, ne? Now we know if it's x plus 1 there, we know that the new asymptote will be -1, ne? So we've gone from 3 to -1. Again, we're going that side, ne? So we know that from 3 to 0 is what? 3 units. But from 0 to 1 will be 1 unit. Therefore, we have moved 4 units to the left, ne? So that will be us. So we have moved 4 units to the left, ne? Based on the x1. And then on the sorry, it's plus 3 here, ne? On the y1, before we're at -2, ne? That's our location, -2. Now we are going to 3 on the new asymptote. Now we're going to 3. So we know from -2 to 0, we have moved 2 units, ne? But from 0 to 3, that's 3 units. So from -2 to 3, we have moved 5 units, ne? And then also we are going up also. So whatever the hx is, you determine the answer. I hope that was also helpful. Ne? So the last thing will be the domain. Last thing that we're going to do is the domain. So with the domain, remember, we know, I think I did the domain already. Okay, I don't know why I did so fast, but I think I did before the domain. Remember, the domain affects your x asymptote. Ne? So domain will be x element of all real numbers, but your x won't be where there's an x asymptote. Ne? But remember, oh yeah, this one is for h. We did the one for f before. This one is for h now. We know that h is having a 0, ne? So there's no x asymptote anymore. We don't have an x asymptote anymore, so we just come back as x element of all real numbers. Because remember, it can't be where there's an x asymptote, and we don't have an x asymptote anymore, so we'll come back as x element of all real numbers, ne? Or just to be safe, also just write X can be where this is 0 because this is 0 now. Just put X, yeah, just put S not 0. And that will be our asymptote. X can be where this is 0 as well. That will be our answer. X element of all real numbers, but X won't be where this is 0. Then that's it. That was a lovely 12 marks. Okay, the last thing I'm going to do is another question now. So on this question, we are given solar eclipse for whatever reason. So now we're given a graph. I think it's better that do one when we're given a graph now. So they're giving us a graph now. Then they want us to derive the equation from the graph now. So like I told you before in our practice equation, it's fx. First thing first, before you stress that much, look for asymptotes now. So remember, a will come back as it is over x, and then we know it's p there. Remember, p goes with x there. So our x asymptote here, it's here. See, this is the x asymptote. This guy going downwards, and that's our x asymptote. And they're telling us here by the coordinate, we know that this is x, this is y. Ne? So using the coordinate, it's telling us that x is -2, meaning this point here must be -2. Then this point here will be 1 based on that coordinate. Ne? So we know that the x asymptote there is -2. Therefore here it must be +2 because there is -2. Ne? And then q will come back as it is. It's 1 there. It will come back as 1. And then are we given a point? Okay, we don't have the point where it's cutting here, but we're given a coordinate there on the graph, which is -3 and 4. Thank you. That will be our coordinate. So x is -3 and then y is 4. So we're going to need that coordinate to draw the graph. Remember, this is y, this is x now. So we need to go and find a now. So y there it's 4 because our aim is to find a now, not the intercepts now. So this will be a x -3 plus 2 then plus 1. So we know now that 1 will go the other side, which will be 4 minus 1 now, and everything will be over a. What is -3 plus 2 will be -1. So this will be 4 minus 1 will be 3 is equals to a divided by -1, and then we can divide here by 1 as well. Then we do cross multiplication, also cross multiplication. So it will be 1 times -3. So sorry, -1 times 3, which will be -3. Then 1 times a, which will be a. So therefore a is that, meaning now our equation will come back as fx. That will be our equation now. It will come back as fx will be equals to a, which is -3 over x plus 2, which we already know from the asymptotes, and plus 1. That will be your 3 marks. Lovely equation. So don't like the example we did before. Look for asymptotes and also look for another point to find the value of a. And then that will be all for hyperbolas. So again, once more, go through other videos on the playlist and check other graphs we have done so far, and then go through them and you'll have fun, because those ones who are writing junior exams, the junior exam will include for grade 11s, which will include all the functions. Same for grade 12s. So this will be helpful if you can master your functions. By default, you've already passed your paper 1. If you can get all the functions good, all the graphs in a good state, then you are guaranteed at least 40% from the graphs alone before you do the cubic ones, which will be for calculus for grade 12s, because grade 11s don't have cubic graphs. So that will be all. And then please guys, comment, because it's always good to engage. And then you can check our Facebook page, TutorNext as well. It's called TutorNext. So yeah, it's called TutorNext, the way the channel name is on Facebook. Then you can send questions that you can go through, and then also you can like and also subscribe. You can tell your friends if they also want to come and listen or join our live sessions. And then that will be all guys, and I hope you guys can learn from this and ace your exams and go to varsity and enjoy life there. And don't forget to subscribe. and like as well. Thank you very much.